Naji here. Welcome to my YouTube channel. In this video, we are going to discuss about transformers and the language models. Nowadays, LLM models are very famous and developers are start fine-tuning the language models. But the truth is, not all language models are suited for all use cases. Okay, so if you select a wrong LLM model for our use cases, we will not get the expected output, and finally we end up with wasting a lot of time and definitely money. So in this video, we will be trying to explain about different categories of language models and its advantages and the use cases. Okay. Attention is all you need. Okay, so that is the start of transformers, and which is released a paper, or Google is released a paper on 2017 about transformers. Okay, then June 2018 GPT's first version is released. Then the same year on October BERT is released, and February 2019 GPT-2 is released, a better version of GPT. Then we have a Distilbert and Barton T5 is released on October 2019, and GPT-3 is released on May 2020. So just a history of the releases. Then we know that nowadays we have a lot of LLM models are available, like Llama 2, BERT, Mistral, and all are like every time new LLM models release, it's better than the old version. So ideally, we can divide the transformer models in three categories. One is GPT-like category, that is called the auto-regressive category or Decoder Only Models. Then we have a BERT-like models, which is called auto-encoding models. Then we have a Barto T5-like, that is called the seek-to-seek models. Okay, so this is the high-level architecture of transformers, and I took it from the paper called Attention is All You Need. Okay, so if you are new to this transformer, no need to worry about this architecture. Just understand that it has two parts. One is called the encoder part. So encoder part will encode all the input text, and we will have a decoder part. So decoder part has a input from the encoder part, okay, and it also get the input from its output also. So consider there is a line from the top to bottom. Okay, so ideally, let me say it again, the decoder will get input from two ways. One is from the encoder. So encoder will get pass its encoder input to the decoder, and decoder will get input also from all the previous words that it is generated. Okay. Now we can go to the first category, that is Encoder Only Models. This is also called BERT-like models. Okay. So as the name says, Encoder Only Model uses only the encoder part of the transformer. Okay. So that is, okay, if this is the architecture, it will only using the first part of the architecture, transformer architecture. Okay. And at any point, attention layer can access all the words, and it is called the bidirectional, which means, okay, consider this. Okay, and this I took from the Hugging Face website, and here consider we need to, so a particular word is masked. Okay, and we need to predict what is the word that is suited here. Okay, in that case, encoder model has access to the words before this masked word and also after this masked words. Okay, and by looking at both sides, the encoder model will predict what will be the word to replace this mask. Okay, so that is why it's called bidirectional, because it is knowledge from left to right and also right to left also. Okay, so here I can show you a picture. So here consider this node. Okay, consider this node. Okay, so you can see the arrow mark. It has all the knowledge from the left side to right side, and also from right side to left side. Okay, so this will be getting knowledge from its first node and second node, also from the last node. Okay, so that is why it is called a bidirectional language model. And usually its pre-training phase, okay, what it usually does is we will be correct few sentences or a few words, and we will ask the encoder model to predict that. Okay, so that is how the encoder model pre-training will work. So encoder model is not good for generation of text. Okay, so maybe sometimes people will use encoder models to generate or train or fine tune the model to generate that, which is actually not good, which will not give the expected output. So please note that encoder models are not good for generation of text, new text, which is actually good in sentence classification. Okay, since it has a entire knowledge of the text, it is easy to classify the text into maybe positive, maybe we send a positive sentence or negative sentence like that. So just example, so we can use the encoder models for the sentence classifications, and this can be used for NER, neighbor entity recognition, and it's also used for extractive question answering. Okay, so that is the major use cases that we use in the encoder only models. Some examples are Albert and Bert, Distilbert, Electra, and Roberta. Now decoder only models. So decoder only models uses only the decoder part of the transformers, and this is also called auto-regressive models. Okay, and auto-regressive model means, consider this example. Okay, this also I took from Hugging Face website. So consider if I pass to my decoder model, okay, then this will predict the next word as name. Okay, and in the next stage to predict is we will be passing these two words, my name. Okay, so we are actually the predicted sentence is also passed to the decoder models. Okay, so that is why it is called a auto-regressive models. Okay, so at each stage we can say that my name, then it is predicting the is. Then to predict Selvia, what we are doing, we are passing these three words to the decoder model. Okay, and we can say that pre-training is done predicting the next word in a sentence. So using the pre-training phase, we will pass a sentence and we will ask them to predict the next word. So this is definitely suited for the text generation, and if our use case is about the text generation, we can definitely use the decoder only models. And example is GPT models, right? Everybody knows about GPT models. So here this is the high level architecture of GPT models. Here we can see it is moving from left to right. So consider this TRM or consider this node, this middle node TRM. It has only knowledge from its previous nodes. Okay, so in a encoder only models, if you see the architecture of encoder only models, we know that if you consider the TRM, it has a knowledge from both sides, right? It has a knowledge from its left side and also from the right side. So when we come to decoder only models, it has only knowledge from its left side. So it is also sometimes called the unidirectional models. And encoder only, okay, so there is a mistake here. Let me correct this. This is okay. No, this is good. Okay, we are good. Okay, so here we have a decoder model. So we discussed about it's suited for the text generation, and which is example is the GPT models. Then we discussed about its architecture. Okay, now we can discuss about encoder and the decoder models. Okay, so this is uses both part of the transformer architecture, both encoder and the decoder architecture. Okay, and encoder can access the entire text and decoder can access the word position before the given word. So that we already explained. And this type of a models or sequence to sequence model, we can also call it a sequence to sequence model. It can be good in summarization and translation from one language to another language, and which is also used for the generative question answering. So examples are BART, T5 and MPART. Okay. So that is all about in this video. So I believe everybody understood about different language models and its categories and its use cases, right? So I believe that this video will be helpful for you guys. So please do like and subscribe. Have a nice day. Bye bye.